This is section 9.1, the Pythagorean triples and the converse of the Pythagorean theorem. So we've already discussed the Pythagorean theorem, so let's just talk about it again. When we have a right triangle, we could label the sides with A, B, and C as long as C is the hypotenuse, and A and B are the legs. And A squared plus B squared will equal C squared. There is something called a Pythagorean triple, which is a set of positive integers that satisfy the Pythagorean theorem. So there are a lot of common Pythagorean triples, and any multiple of those numbers will also work. So the most common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, and like I said, any multiple of those numbers. It's not required to memorize the Pythagorean triples, but they are helpful to know because you may recognize it as you're doing a problem, and then it saves you the work of having to complete it. Because if I already know I have a hypotenuse of 17 and a side of 8, my last side's going to have to be 15. All right, if I'm asking you to solve for x and then determine if it's a Pythagorean triple, we're just looking to see were all three numbers integers. So for our first example, let's find the value of x and tell whether the sides form a Pythagorean triple. So I'm always going to identify my c value. So opposite the right angle is c. So that means 8 and 13 are a and b. 8 squared plus 13 squared equals x squared. If you recall, we're going to square the 8. We're going to square the 13. And we're going to have it equal to x squared. I will combine these. And I will get 233 equals x squared. And now my last step would be to take the square root of both sides. And I'm going to round this to the 10th, so it's 15.2 to 15.3. So is this a Pythagorean triple? Well, my sides are 8, 13, and a decimal. So no, because that last number was not an integer, right? It was not a whole number. All right, the next one. So if I look at my right angle, across from it is C, so 5 is my C, x and 3 are A and B. So x squared plus 3 squared equals 5 squared. So that's x squared plus 9 equals 25. Subtract 9, we get x squared is 16. And when I take the square root, we get x is 4. So my sides were 3, 4, and 5. All three were whole numbers. So yes, that is a Pythagorean triple. So you go ahead, try the next two. Pause. When you're ready to see the answer, hit play. All right, let's get this so we can see the whole thing. So for the first one, we get x is 7, and yes, that is a Pythagorean triple, 7, 24, 25. For the second one, I get 5.4, so no, that was not a Pythagorean triple. All right, this problem is actually pretty tricky. We have to find this entire length of x. But this big triangle here is not necessarily a right triangle, right? There's no right angle symbol here. So what I'm going to have to do is I'm going to have to create two different right triangles, find the values of both of these parts, and add them together to get the length of x. So let's call this side A, right? A, B, C. So that would be a squared plus 12 squared equals 14 squared. So if I subtract 144 from 196, I get 52. And when I take the square root of both sides, I get 7.2. Now I'm going to do the same thing, but with this triangle over here. All right, let's call this B. We have 12 squared plus B squared equals 29 squared. So we are going to 144 plus B squared equals 841. All right, if we subtract the 144 from both sides, we get 697. And now we'll take the square root, and we get 26.4. So x is really 7.2 plus 26.4, which is 33.6. All right, you're going to try the next one. Pause and hit play when you're ready to see the answer. If you are stuck and you want to see a way that we would do this, I would recommend first taking this right triangle here and finding the value of a and leaving a as a square root. Don't get the decimal, because when you then put it back into the other triangle, it'll be easier to work with. So now pause, and when you're ready to see the answer, hit play. All right, so I did my purple triangle here first. I pulled B when I did my triangle instead of A. So I have 10 squared plus B squared is 25 squared. I get B is the square root of 525. Or if we were looking at the one that I had set up for you, A was the square root of 525. So now in my bigger green triangle, I'm keeping this as the square root of 525. 28 is my C, so it's x squared plus square root of 525 squared plus 28 squared. And the really nice thing that happens is the square root symbol cancels out when I square it. So we get x squared plus 525 equals 784. Subtract the 525, x squared is 69, and x is 16.1. All right, we'll do some more later involving squaring when we have a square root. So here we have a roofer leaned a 16-foot ladder against a house. So what I would do is I'm going to look at my picture. Here's my house. Here's the ladder leaning against it, right? The ladder is 16 feet long. The base of the ladder is 5 feet from the house. So if this is the base of the ladder and this is where the house was, this is 5 feet. How high up the house does the ladder reach? So we're looking on the house. How high does it go? So we will often be asked to draw pictures to represent a situation. And now I know I'm going to have 16 as my C value, x and 5 on my A and B. So x squared plus 5 squared equals 16 squared. So we get x squared equals 231. Take the square root of both sides. We get 15.198. So we would say 15.2. And now it's asking how high up does it reach? 15.2 feet. So you're going to try the next one. Same idea. We have a 31-foot support wire attached from the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? Pause. When you're ready to see the answer, hit play. All right, so the wire was 31 feet, the pole was 25 feet, and we're looking for how far on the ground it was away. So x squared plus 25 squared equals 31 squared. We get about 18.3. So that's 18.3 feet. So the converse of the Pythagorean theorem is if you can take three numbers without necessarily knowing it was a right triangle, if you could take three numbers and a squared plus b squared does equal c squared, then we can say the triangle is a right triangle. So here we want to determine whether the sides of the triangle are right triangles. We might already recognize this. Let's check anyway. If I plug in 3 squared plus 4 squared equals 5 squared, and I'm choosing 5 because it's the biggest. So I'm going to get 9 plus So that answer is yes. Both sides did form a right triangle. All right, let's try another one. I'm going to make 9 my C. So it's going to be 4 squared plus 7 squared. Checking to see if it equals 9 squared. So 16 plus 49 and 81. So 16 and 49 is 65, which does not equal 81. So no, these three sides do not form a right triangle. All right, here I have 8, 7, and the square root of 13, which is the biggest side because it's over 10. So I'm going to use that as my C. So 7 squared plus 8 squared is, I don't know, equal to the square root of 13 squared. So this is 49 plus 64. And here, when I have the square root of 113 squared, I do not take the pencil. I'm just going to cancel out those two things, and it becomes 113. And 49 plus 64 is 113, which does equal 113. So yes, these sides did form a right triangle. Oh, even trickier. All right, so here's my C value. And we are 15 and 36. So 15 squared plus 36 squared. Checking if it equals 4 root 95 squared. So 15 squared, we get a number. 36 squared, we get a number. So here, when I'm squaring this, I'm really squaring both parts, and it's still being multiplied. So 4 squared is 16, and the square root of 95 squared is 95, because that's the part that cancels out. So this side is really 16 times 95. So 225 plus 496 is 15. 1, 16 times 95 is 1520. So they do not equal. It's very slightly off. So no, this does not make a right triangle. So you go ahead and try the next two. Pause. When you're ready to see the answer, hit play. Oh, there was a third one on there. Sorry, you didn't get to see it before. Let me make the whole page big so we could see all of them. So the first one, 9 and 15 are A and B, is 34. So 80 plus 65 is 6, and I squared 64 is 29. So equals 6. Yes, that would work. This one, I know the square is just only numbers, and I can know that and the one you didn't get to see is 5, 7, 13. So 5 squared is 4 squared, 25 plus 34 is 9. So yes, that would have formed the right. So now we have some kind of additions to the converse, which are our Pythagorean theorem inequalities. So now, not only can we tell if a triangle is a right triangle by using the Pythagorean theorem, we could tell what kind of triangle it is, whether it be obtuse or acute, if it wasn't right. For these, I'm going to see that a little bit of a these parts are linear surfaces way, because if it's greater than c squared is greater than a plus b squared, it's an acute triangle. And c squared is less than a plus b squared, it's an acute triangle. Right? And it only makes sense to words if c squared comes first. So my three sides are 18, 11, and 14. 18 is my C. So we're going to start with that. 18 squared is something. 11 squared is squared. So we're going to get 324 is something to 121 plus 196. And I add these together, I get 317. So what I really have is this So greater than means I have an obtuse triangle. All right, and this one, my biggest side is 26, so that's my C. We're going to have 26 squared is something to 14 squared plus 22 squared. So we get 676 is something to 196 plus 484. Adding together the 44 and 196, we get 680. So 676 is less than 80. So that's an acute triangle. So you go ahead, try the last two. Pause when you're ready to see the answer, hit play. All right, so for check-in number 7, 23 was my biggest side. I end up with 529 is less than 579.4, so that's an acute triangle. For the second one, number 8, 7.1 was my biggest side, so that's C. I end up with 50.41 is greater than 45.43, so that was an obtuse triangle. And that is everything we need to know about the Pythagorean theorem and its converse.